What if the world around you isn't really solid? What if the floor under your feet, the chair you're sitting on, even your own body are all mostly nothing? That might sound impossible, but quantum physics says it's true. So if the world isn't what it looks like, then what is real? Let's start with the biggest illusion of all, the feeling that the world is solid. Tap your hand on a desk. It feels firm. It doesn't pass through. You trust that what you see and touch is real. But if you zoomed in deep enough, far smaller than any microscope could see, you'd find something shocking. Everything you see is almost entirely empty space. Inside every atom is a tiny nucleus surrounded by a vast region where electrons might be. If an atom were the size of a football stadium, the nucleus would be a speck of dust at the center. The rest is space. So why doesn't your hand fall through the desk? Because when you press down, the electrons in your skin and the electrons in the desk repel each other. They never actually touch. What you feel as solid is the force between invisible charges pushing back. It's like trying to press two magnets together with the same side facing each other. You can't make them meet, but you can feel that push. That's what touch really is. Invisible forces keeping atoms apart. Our senses aren't built to see that level of reality. They're built to keep us alive. They turn a storm of invisible particles into something steady enough to walk on and hold. The world feels solid because our brains simplify it. But the truth is, solidity is a clever illusion. We live in a world that only seems still. Underneath, everything is vibrating and alive. But the strange part isn't just what things are made of, it's how they behave. Quantum physics revealed something that sounds impossible. The same thing can act like both a wave and a particle. Here's how scientists found that out. They fired tiny particles like electrons through two thin slits toward a screen. When no one checked which slit they went through, the particles didn't act like little bullets. They made a wave pattern, as if each one passed through both slits at the same time. Then they tried again, but this time they watched which slit each particle went through. The wave pattern vanished. The particles started behaving like solid bits of matter again. That simple experiment, called the double-slit experiment, changed how we understand everything. The act of measuring changed the outcome. When not observed, reality acted like a cloud of possibilities. When observed, it became one clear event. So which is it? A wave or a particle? Both? It depends on how it's measured. That sounds strange, but it's one of the most tested facts in science. At the quantum level, the world doesn't move in straight lines. It exists in probabilities. A particle can be in many states at once, something called superposition. It's not here or there, it's here and there until something forces it to pick a place. When that happens, the wave of possibilities turns into one definite reality. Before that moment, everything exists as potential. After, only one version remains. The universe doesn't follow common sense. It follows quantum sense, and that sense is far stranger than anything we experience in daily life. Now comes one of the most misunderstood ideas in all of quantum physics: the observer effect. It's often said that observing something changes it, and that's true, but not in the way most people think. Observation doesn't mean a pair of human eyes watching a particle. It means any interaction that collects information. When something interacts with a particle, like a photon bouncing off it or a detector recording it, that interaction forces the particle to take on a definite state. The act of measurement ends the particle's game of being everywhere at once. Some people believe this means consciousness itself creates reality. Others say it's just physics. They argue that any kind of interaction counts, not just awareness. No one fully knows the answer, but the question itself changes how we think about existence. If consciousness does play a part, then maybe reality and awareness are linked in ways we don't yet understand. But even if it doesn't, the fact remains that interaction shapes what becomes real. It raises a deep question. Is reality something that exists on its own, or does it depend on relationships and information exchange? Here's where things get even more mind-bending. What if every possible outcome of a quantum event actually happens? Not just one, but all of them, each in a different universe. That's the idea behind the many worlds interpretation. In this view, the universe doesn't collapse into one version of events. It keeps them all. When a particle could go left or right, both paths happen. each in a separate universe. When you make a choice, every other possible choice continues in another branch of reality. You might be watching this video right now. In another world, you clicked on something else. Both versions of you exist, living out different futures. That means there could be infinite copies of you, each living a different version of your life. It sounds unreal, but some physicists take it seriously because it solves a big problem in quantum theory. It removes the need for wave collapse. Nothing disappears. Every outcome continues somewhere. It also challenges our sense of identity. If every version of you exists, what does it mean to be you? Maybe you're not a single story, maybe you're one thread in a much bigger web of possibilities. It can be unsettling to think about, but there's something freeing about it too. Every possible path exists. You just happen to be walking one of them right now. Some scientists think there's something even deeper behind all of this. They believe that reality itself might not be made of matter or energy at all. It might be made of information. This idea comes from quantum entanglement. When two particles become entangled, they share a connection that can't be explained by space or time. Change one and the other responds instantly, even if it's on the other side of the universe. Einstein didn't like that idea. He called it spooky action at a distance. But modern experiments show it's real. The connection between those particles doesn't seem to travel through space. It's as if the information that links them exists outside of space altogether. That's what led some scientists to think that information, not matter, might be the foundation of everything. Space itself might be built out of information links, like the code of a vast cosmic network. That doesn't mean the universe is a computer simulation, though some people like to take it that way. It means that everything we call real might be patterns of information interacting with other patterns. If that's true, then the universe isn't a machine made of cold matter. It's a living system of relationships and exchanges. Reality becomes less about objects and more about connections. And in that view, consciousness isn't something separate from the universe. It's another way that information processes itself. Awareness could be one of the universe's own ways of knowing what it is. So maybe the question isn't what is real, but what does it mean to be part of reality? Quantum physics shows us that the universe is both predictable and uncertain, both orderly and wild. That might sound confusing, but it's also deeply human. Every one of us lives between what we know and what we don't, between what's visible and what's mysterious. Quantum physics isn't just science, it's a mirror. It shows us that uncertainty isn't failure, it's the foundation of everything new. Reality isn't finished, it's still being written, and you're part of the sentence. What do you think reality truly is? Comment your thoughts below, and don't forget to like and subscribe while you're there.